Assalamu alaikum. Welcome to lecture number 23 of Software Requirements Engineering, CSE305. In today's lecture, we are going to continue with our process of requirements validation within Software Requirements Engineering. What we covered in our last lecture, we started with our discussion on the specification process. And we specifically looked at specifying non-functional requirements for critical systems. Before we briefly recap that, let's quickly try to also go back and see what were the critical systems. So we said there are three kinds of critical systems. There are business critical systems, there are mission critical systems, and then we have safety critical systems. And the importance of specifying these non-functional requirements for these systems is increased or amplified because of the fact that that usually the functional requirements, they are testable, and we can run lots of test cases and we can validate that whether these requirements are working or the product is behaving as we expected it or not. But generally these softwares, they fail because of these non-functional requirements. They are not performing as the client wanted. So the importance of NFRs for these safety critical systems or for critical systems increases a lot. And we discussed that there are 5 kinds of non-functional requirements which we have to take care of when we are talking about critical systems, and that included the first of those 5 non-functional requirements that we consider when we are specifying requirements for critical systems was reliability. Now we know reliability is very important for any system or for any product that we are developing, but for safety critical system, reliability is why it's so important, because we are talking about huge amounts of losses, whether it's in terms of resources or whether it's in terms of human life. So we don't want our critical system to be unreliable. So we want to know exactly for how much amount of time our system would be unavailable. Okay. And we discussed that reliability can be described in 2 terms. Number 1, it can be described in terms of availability. And when we are talking about availability, what we do normally is we say that for what portion of time my system won't be unavailable. And secondly, we can also specify reliability in terms of failure rate. That what is the failure rate of my system? What is the rate of occurrence of failure in the system? Or the other measure or the other metric that can be used to describe the failure rate is mean time between failure. So, or mean time to failure. So we try to. It is very important. It is imperative that we know that these non-functional requirements, although these are constraints and these are goals of the client, but for these critical systems they are of utmost importance. And the unavailability time or the failure rate, our product has to conform to those values whatever we specify, and these has to be some quantitative value when we are specifying reliability requirements for critical systems. Second was performance. And we said that performance can be described in a number of ways. It can be related to the timing. So the timing requirements of the product, they can be considered as performance requirements. And by timing, we mean that if our product has to poll another hardware, for example, if the product that we are developing or the system that we are developing, it has to poll certain sensors. And so we need to know that at what time our system should poll the sensor. Similarly, if our system has to generate an output which would be used by another software, or that output would be used by another user, the timing of that output is important. If it's important, then we need to mention that at what time this should be generated. Similarly, another kind of performance requirement are throughput requirements, that how many transactions my system should process in a certain amount of time. So for example, we say our system should process 20 transactions per second or 8 transactions per second. So again, we need to quantitatively describe the throughput of our system. And then we have the response requirements, that how quickly my system should respond to the user. So again, all these requirements, whenever we are talking about performance, we need to mention these requirements in a quantitative fashion. So the third type of non-functional requirements we talked about when we were discussing those critical systems was security requirements. So again, when we talk about security, obviously we also worry about the security of any other normal system that we are making, but because it's a critical system and we don't want unauthorized access to the system or to the data that I have stored within the system, it is very important that it is categorically mentioned that what type of users are allowed which type of access. Similarly, if we need to take backups of our data, these also need to be mentioned, that at what times the backup will be made. And similarly, if we have to store our data somewhere, then we need to mention very clearly that whether the backup would be taken in a server which is off-site or which is on-site, and whether we are using any encryption algorithm to encrypt our data. So all these things that we need to be very careful when we are mentioning. It depends. Obviously, it depends on the system that we are making. If the system is storing lots of very important data which we don't want to be accessible by all the people, and we want to encrypt it, and we want to ensure that only certain kind of people are allowed access to that kind of data, then we need to mention those requirements very clearly. Then the fourth type of non-functional requirement for critical system we discussed was safety. And there is one thing very interesting about safety that we discussed, that there is no formal definition of what would be classified as safety requirements. And we just said that when we know our system and we know the application domain of our system, we know the boundaries and we know the scope of our product. And we know there are certain things that my system should do, and there are certain things which the system should not do. So when we are mentioning safety requirements, so we should all the shall nots. So for example, we looked at multiple examples, and one of the examples that we looked at was that if you have to give a certain amount of sedative to a patient, then the dosage of that sedative would be determined by the physician. Okay, and the system that we are making, it shall not give the dosage more than what is prescribed by the physician. So we know that this is a behavior that is not acceptable. So all these kind of behaviors, all the things which our system shall not do, which would breach the safety, so they all come into this category of safety requirements. So that was the fourth kind of non-functional requirements that we have to be very careful about when we are specifying requirements for critical systems. And the fifth kind of non-functional requirement that we discussed was usability requirements. And again, we have discussed that usability is very important, and if a system is not usable, if any system is not usable, people are not going to use it. But in terms of usability of critical systems, it is very important that, so when you're talking about general system that we are making, we talk about usability in the sense of ease of use of the product, and we want the product to be easily learnable. So obviously these things also stand true for these critical systems, that we want to ensure that the product is usable and people can learn it very quickly. Similarly, people don't make lots of mistakes when they are using this particular product. But there are some added constraints when we are talking about usability for critical systems. For example, if there is an error, then the error messages should be a lot more detailed, and they should guide the users to help them identify what the problem is, because we are talking about critical systems, and we want the product to be so easily usable so that we don't miss any of those performance constraints that we have already put on the system. So how do we ensure that the product is usable? So there are lots of metrics that can be defined. As I said, we can define a metric that how quickly people can adapt to this new system. Similarly, we can also record the number of errors people do when they're working at the normal speed. Similarly, we can also do some likability test, and what's the best way of determining whether people actually like the system or not is to conduct a survey. So you prepare a questionnaire and you float it around and ask the people whether they actually like using the system or not. So these are the 5 types of non-functional requirements that we have to be very careful about when we are specifying them for critical systems. And as I have said repeatedly, that although we mention these requirements for other systems as well, but the importance of mentioning these requirements in a measurable fashion for critical systems is way more important than for any other system. Following that, when we are finishing our discussion on specification, we discussed a checklist of non-functional requirements, and those checklists, they included all the non-functional requirements that we have discussed in our past 2 lectures, and their checklist included requirements on availability, efficiency, flexibility, portability, performance, reliability, reusability, robustness, scalability, usability, and integrity. So all these non-functional requirements, why I am saying that we need a checklist, normally these checklists are used to ensure that you have not skipped on anything. And this is the purpose of having this checklist here. You have definitions of these terms, and when you have specified your non-functional requirements, you go through your SRS or the work product that you have produced, where you have specified your requirements, and you try to identify that user gave me a concern about availability of the product. Have I mentioned it clearly here? No. If no, then you need to specify it. Similarly, about portability. Now, there is always a portability requirement. For example, user would always tell you that, you know, they would want to run this product on what platform. So these requirements, they need to be explicitly written. Okay. If the user expects your product to be on multiple platforms, if you don't specify it, then the user can argue that this is not working on a certain platform if you only make it for one platform. So this is very important that all these requirements are clearly mentioned, and this checklist is very helpful and very useful, that you go through each definition of each of these non-functional requirements and you try to determine whether there was a need to specify this non-functional requirement which you have missed. Then you try to do that again and try to fix your final specification. So that was our discussion on the non-functional requirements and non-functional requirements for critical systems, and finally checklist to determine whether you have not missed or whether you have mentioned all the non-functional requirements during specification process. So, and then we moved to the validation process, which is the next process in the software requirement engineering, or which is the next sub-process in the list of requirement engineering processes. And we discussed this process in a way that normally I like to discuss all the processes. We said that, let's say this is my validation process, then what are the inputs to this process and what are the outputs to this process? Just remember this definition of a process, and this actually makes it very easy for everybody to comprehend that what's happening in validation. So we said that as the name suggests, the name of this process is requirements validation. So we know that we are going to validate the requirements that we have written. So one of the very key inputs to this requirements validation process is the software requirement specification document that you have produced after specification. So let's say this was my specification process. So we discussed is that one of the key outputs of the specification process, or the key output of the overall requirement engineering process, is SRS. So this SRS is the input to this validation process, but there are two other inputs to this process. And at times we say these inputs, they may be written, or this knowledge, it can be implicit, it cannot be explicitly written. And what does these other two inputs are? One is the organization knowledge, and the other is organizational processes. So these are the three inputs to validation. Right? And then what outputs do we get from validation? So the outputs that we get from validation are corrective or agreed actions. And secondly, the list of problems for which we have to take these corrective actions. So there are two outputs and there are three inputs to this validation process. And then we try to expand this this bubble, and we try to figure out, okay, this is the validation process, but what happens inside this process? Right. And we discussed two of the sub-processes, or two group of activities that we perform within validation. The first one was the requirements review process, and the second one was requirements pre-review process. Okay. But before we get to it, I just want to go through this particular slide where we mentioned the validation objectives, and then we'll go back and talk about that requirements review process and requirements pre-review process. So let's quickly recap what was validation for. So we said that it certifies that the requirement document is an acceptable description of the system to be implemented. So acceptable by the client, obviously, or acceptable by all the stakeholders. So what do we check in a validation process? We check the document for completeness and consistency. So we try to ensure that it includes all the things that were discussed during elicitation, that were discussed or analyzed during elaboration or analysis phase, that were negotiated earlier. So it should include everything. And the document is consistent or not, whether we have mentioned same process in two different manners or not, whether we actually miss something during analysis and there are still inconsistencies in this particular document. And then conformance to standards. If that's why, if you guys remember, two of the inputs to the validation process included organizational knowledge and organizational standards. So what we try to ensure is that the document that we have produced, whether it conforms to standards or not. Okay, so for example, let's say we as an organization have our own template of specifying software requirement specifications. And when we specify requirements for every client, we need to conform to that standard. So if the document is not of that standard, then okay, this is not, there are some problems. So we will list all the problems with the standard, and then we say, okay, fix it, and then we will consider your software requirement specification document. And similarly, at times, as I mentioned repeatedly during the course of during these lectures, that at times client can also put certain constraints, and client might have their own standards which you have to follow. So it can vary. It can be either your standards or the client may constrain the way you produce certain work products. And then you will also try to identify, are there any conflicts in the requirements? Okay. And then are there any technical errors in the requirements, something you have mentioned which is not right? For example, a formula that you have mentioned and which applies to a certain application domain, and when you present those requirements to the clients or to the stakeholder, they identify, no, this is something seriously wrong. So that is another purpose of this validation process. Then finally, we also try to list if there are any ambiguous requirements still left in the SRS. But these list of things that we do during the validation process, it can cause slight confusion as well, because we already talked about that we do all these things when we analyze our requirements. So we discussed some of these things during analysis. Apart from maybe the conformance to standards bit, we discussed all these things earlier, and maybe technical errors. So for example, these three things we've already talked about. So we say that we do it during analysis. So then the question becomes that what is the difference between validation that we are discussing right now and analysis? So what is the difference between the two? Then that becomes the question. So, and there is a very slight difference between the two, but that difference should be evident, that what we do in analysis is performed on raw requirements. So we should remember that we try to perform analysis and we try to elaborate requirements on raw requirements which have been elicited from the client. Okay, so this is raw text or raw scenarios or raw user stories on which we try to do analysis. Whereas validation is performed on final requirements, or I should not say final requirements, it is performed on software requirement specification document, where you have explicitly listed, these are set of requirements that our product should, or these are the set of the features that a product should have. So there is a difference, that one is performed on raw requirements, the other is performed on final set of requirements. And normally what is said that during analysis, the question that we try to answer is that have we got the right requirements? So the question that we try to answer is that during elicitation, the requirements that we have gathered, have we got the right requirements? And during analysis, this is a very subtle difference, that during validation, what we try to say is that have we got the requirements right? So there is a very small difference during analysis. So this is what we do during analysis. So number one is that analysis is performed on raw requirements, and validation is performed on final requirements. So this is validation. This is performed on final set of requirements. So we say that during analysis, what we try to check is that have we got the right requirements? So we try to ensure that the user stories or the scenarios that we have gathered from the client, whether they are correct or not. But during validation, what we try to validate for is that we have now specified those requirements explicitly. So from scenarios, we have derived all the functional requirements. From concerns and goals, we have decomposed and we have got to specify all the non-functional requirements. Now what we try to ensure is that whatever we have written, whether that is correct or not. So there is a very small difference, but if we look at these processes in detail, look at the analysis process, what was the input to the analysis process, what was the input to the validation process, there is a clear difference between the two. So validation, it stands apart from analysis. So do not get confused by looking at these three terms. When we say that when we do validation, we check the document for completeness as consistency, we check the document for any sort of conflicts, we check the document for any sort of ambiguous requirements. There are two other things obviously, but do not get confused by this. So validation we do it to determine have we got the requirements right or not. Okay, so we were discussing, we said that we will come back to, once we discuss the validation objectives, we'll come back to the requirements review process that we covered in our last lecture. So we said there are two things that we discussed in our previous lecture about validation. We said we do a review of the requirements, so a list of activities we perform to determine what's the problem with the SRS document that I've produced. And then we can also have another group of activity which is called the pre-review process. So first of all, let's look at the requirements review process. So we have a process within validation which we call requirements review process. So what do we do in this requirements review process is that it consists of a group of activities. We say we plan a review. Then what we do is we try to distribute all the documents. Then obviously the document that is distributed to different team members who are part of this review team, they have to prepare for the review. So they prepare, and next we have is that we conduct this review meeting. So we hold that review meeting, and then follow-up actions are taken. So for example, whatever was decided in that meeting, you need to follow it up as well. And then you have this, you revise your document. So you are going to revise your document. So these are the activities that are performed during this requirements review process. So the first activity, it says that you need to plan the review. And when we were discussing this requirement review process, I said something about formal reviews. So this is something that you guys must have gone through during your software quality assurance course, or you will go through. The formal reviews, very briefly, normally they are timed. Okay, there are two types of reviews which are performed, or inspections which are performed when we try to ensure quality. On one hand, we have these formal reviews, and on the other hand, we have informal reviews. The formal reviews, they are timed, they are already planned, and they are usually longer than informal reviews. And as I said, that informal reviews, they are not timed. They are sort of random inspections that you just randomly go and ask one of your teammates, okay, what are you doing? And if he's producing or working on a certain type of document, you do a walkthrough on it. Whereas the formal reviews, they are already planned and they are scheduled. And normally the time is allocated for these reviews, and it is already pre-decided that on what sort of work products the reviews would be conducted. So for example, as I said, that software requirement specification is one of the key work products. So it will be already planned that when the software requirement specification document is complete, a formal review would be conducted on it. So this plan is already in place, that you plan this review. Okay. But what planning can include is it can also include is sort of try to identify that who would be the stakeholders who would be included in this particular review meeting. So you identify all the stakeholders as well who would be included in this review meeting. And what is then done is that all the documents, all the inputs. So as we said that there are three inputs to this validation process. One is software requirement specification document. So one of the document that is distributed is software requirement specification. Then if you have any organizational standards document, you will also distribute that. Any templates that you're following, you will distribute that. So all the documents, they are distributed to all the stakeholders who would be part of this review meeting. And then all those team members, all those review team members, they will given time to get prepared for that review. So they would go through all those documents and they would try to list down. So they would try to list down all the ambiguous requirements, all incomplete requirements, all inconsistencies. They will also try to list down, any standard violations. So when they would prepare for this review meeting, they would go through this whole document and they would have already listed down all the problems. And then comes this review meeting. So which is where all the stakeholders, they are sitting together, and maybe producer of the document, they will also present this SRS document, and one by one everybody would have listed all the problems. They have already gone through it, so there would be a discussion on those problems. Okay, and through that discussion you are going to decide, okay, whether what kind of a problem it is. Does it need a major review or does it a minor problem? And based on that you will decide on the follow-up actions, that what would be done. If it's a very small problem, then you will just revise the document and your document would be finalized and validated. If there are bigger problems, then you might have to go through re-review again, and your whole SRS document would be reviewed again. So the follow-up actions, they are decided, and then you revise the document based on what actions were decided or what actions were agreed upon. So this is the requirements review process. But one thing we mentioned as a part of this formal review, that because they are timed and you take a lot of time of all these people who would be part of this review team. So we ask them to be present for a certain amount of time, then a lot of time is taken to actually prepare for this review meeting. So if your document is of substandard quality, and you know yourself this document is not good enough, and you go through with this formal review process, then what would happen is that you are going to waste a lot of time of lots of people, and which is actually not good. So, and your client might be pissed off that this was a very horrible document. So he might have questions in his mind that whether I've chosen the right contractor or not. So it is very important to ensure that when you go for this formal review, then your document is of very good quality. So what is normally suggested is that before going for this formal review, you conduct an informal review. So we say that you have a pre-review. Okay. And what would you do in a pre-review is that you will ask one of your teammates or a couple of your teammates to walk through to your document. And what they would do is that it will be like an informal review where somebody from the software process engineering group or somebody from your own team or somebody from the SQA group, it would be assigned to go through your document. And what they would do, they would try to figure out all the typing mistakes, all the grammatical mistakes, all inconsistencies or incomplete requirements, because some things they are very easy to identify. Maybe those people, because they are not domain experts, let's say, they are not able to identify any technical problems, but they would figure out if there are any typing mistakes, if there are any missing requirements, and they would also be able to identify if there are any inconsistencies. So it's always a good idea to go through a pre-review process before actually going through this formal review for validating your software requirement specification document. So that is what we discussed in our previous lecture. And I wanted to emphasize on few of those things, so we spent some time on these things again. So in today's lecture, we are going to continue our discussion with this requirements validation process. And we just discussed the formal review process. So how do people becomes member of this review team? Who are the members of this review team? So the review should involve a number of stakeholders drawn from different backgrounds. So it is very important to actually understand, because you as a company are responsible for producing this software requirement specification document for your client, and now you need to involve people who would be able to validate this final set of requirements. So an important question then becomes that who should be that people who should actually be part of this review process for validating your SRS. So people from different backgrounds bring different skills and knowledge to the review. So what we ideally want is that we need to pick people from different backgrounds. So for example, as we have given example of learning management system for a university for repeatedly. So let's say, for example, you're making or you're automating a certain campus of a certain university. Now what you would want is that you would want people from different backgrounds. So let's say this automation involves automation of the finance, the administration, students registration, and course register. All these things are included in this particular product. So you would ideally want people from different backgrounds. Maybe you would want finance people, you would want accounts people, you would maybe want some faculty members, you want people from administration, you want students as well. So you would need different people from different backgrounds who can identify conflicts, who can identify problems, who can identify technical errors, who can identify ambiguities in the document. Because what that would ensure is that when different people are coming from different backgrounds, they have different viewpoints, and then when they sit together, then they are able to see the problems, and then they are able to identify conflicts as well. So stakeholders feel involved in the requirement engineering process and develop an understanding of the needs of other stakeholders. So again, this is another chance of having those people with different skills, different backgrounds sit together and try to realize that, okay, this process is not just for me, but we are automating this process to ensure that the whole organization achieves its goal. And at times, what I think, maybe it's not given priority because overall it does not conform to overall goals of the organization. So when people sit together, they actually do realize that, and it's a good chance to actually go through and do that again. So review team should always involve at least a domain expert and an end user. So this is a minimum, that you should have at least a domain expert, which might be somebody from your side or which might be somebody from the clients, and it should involve an end user as well. So by end user, we mean somebody who is actually going to use the system. Okay. So this is how we decide that, what sort of people to be included in a review meeting. So we say that people from different backgrounds and different skills, it's always a good mix to have those people sitting together, and we discussed that there is advantage of that as well. Similarly, at least we have said that your review team should include a domain expert and an end user. So what are the review checklists? What are the things that we need to ensure that, once we have conducted the review, what are the things that we need to ensure that, okay, we have done this review thoroughly? So number one is understandability. Can readers of the document understand what the requirements mean? Okay, so the first thing is that the document that you have produced, whether it is understandable by all the readers or not. So that is the first thing that this review should do. Second is redundancy. Is information unnecessarily repeated in the requirements document? So are you trying to mention the same requirements in different ways, or are you actually putting in lots of information which, as you have already said, and you're trying to repeat yourself again and again? So you try to identify all the redundant information in the document. Third is completeness. So does the checker know of any missing requirements, or is there any information missing from individual requirements descriptions? So you need to check your requirement for completeness. And we looked at the example of some of the completeness requirements in our last lecture as well. So ambiguity. So are the requirements expressed using terms which are clearly defined? So ambiguity we discussed there can be number of type of ambiguities. So for example, you're using abbreviations. So you need to have a list of acronyms in your document where you try to mention, okay, that what does this term means. And if it is not defined, then obviously this requirement becomes ambiguous, because some people might understand it, but others may not. So it is very important that your requirements, that in your review process, you check your documents for ambiguities. And another aspect that we check in ambiguity is that could readers from different backgrounds make different interpretations of the requirements. So this is also very important, that we want a single interpretation of the requirements. So if multiple people are thinking it in a different fashion, then it means that there are ambiguities in this requirement. So this is the fourth thing that we check during the review. Then comes consistency. So do the descriptions of different requirements include contradictions? So we saw that there can be multiple sort of conflicts. There can be logical conflicts. There can be very simple conflicts where we have mentioned a process in two different fashions, and we discussed that we can have different formulas written for same calculation. We may use different terms for the same process. So all these are consistency problems. So we need to ensure that there are no such problems. Another aspect that we check during consistency is that are there contradictions between individual requirements and overall system requirements. So we need to check for those contradictions as well. Then comes the organization bit that we need to ensure. So for example, what we need to do during when we check that the document is conforming to organizational standard is, so we say that is the document structured in a sensible way. So that is the first bit. And or the descriptions of the requirements organized so that the related requirements are grouped. So this is very important, and this is something which I mentioned in our earlier or in our initial lectures of this course, that normally when you specify these requirements, then the requirements which are related to one functionality or one process, they are grouped together. And the idea is that when people go through that document and then they develop an understanding of a particular process, if all the requirements are written together, they won't have to context switch to another process and then think about this process again. And if there are any ambiguities, any conflicts, any contradictions, then you would be able to identify them, because all the requirements related to this particular process, they are written together. So it is very important that the document is structured in a good fashion, or the organization of the document is actually good. So when we say organization, it does not mean conformance to standards. Actually, it means how the document is organized. okay, whether the requirements are grouped in a sensible fashion or not. Then comes the conformance to standards part, which says that does the requirement document and individual requirements conform to defined standards, and we have discussed this in detail, that what do we mean by standards, and are departure from the standards justified. So there can be scenarios, there can be examples where you might have to change a bit. For example, you introduce a new section in your SRS document, and that is required for this particular client or for this particular product, but there needs to be a justification for that. Then final one is traceability, that are the requirements unambiguously identified, include links to the related requirements and to the reasons why these requirements have been included. And if you guys remember, one of the example SRS document that we looked in our earlier lectures was of a bus locator project, and we said that within we saw that when we were mentioning the requirements, they were different. It was in a tabular fashion, and we had different fields. So we were trying to define dependencies of a requirement. For example, if a requirement is dependent on another requirement which is already mentioned, we were mentioning that. We were also trying to list what is the rationale of including this particular requirement. So all these things, they increase the understanding of the document, and it make it easy for people who are reviewing this document to properly validate your software requirement specification document. So what are the checklist questions that people should keep in their mind when they are actually reviewing the document? Is each requirement uniquely identified? Are specialized terms defined in the glossary? Does a requirement stand on its own, or do you have to examine other requirements to understand what it means? Do individual requirements use the terms consistently? Is the same service requested in different requirements? Are there any contradictions in these requests? If a requirement make reference to some other facilities, are these described elsewhere in the document? Are the related requirements grouped together? If not, do they refer to each other? So this is a list of questions that a reviewer, or whenever you are part of this review team, you should have in your mind. These are the things that you have to ensure when you are reviewing a software requirement specification document, when you are validating that particular document. So let's look at some of the requirements problem example. So for example, it says EDIS will be configurable, or EDDIS will be configurable so that it will comply with the requirements of all the UK and international copyright legislation. Minimally, this means that EDIS must provide a form for the user to sign the copyright declaration statement. It also means that EDIS must keep track of copyright declaration statements which have been signed, not signed. Under no circumstances must an order be sent to the supplier if the copyright statement has not been signed. So if we look at this big statement, then there are lots of problems that we can identify. And so let's look at what are the problems with this particular requirements description. So number one, there are few completeness issues, and there are some things which have not been clearly mentioned. So for example, there is a discussion about international copyright legislation, but it is not mentioned that which one is relevant. So what international copyright legislation is relevant, that is not mentioned. What happens if the copyright declaration is not signed? So this is again not mentioned. There is a discussion about signed or unsigned, but what would happen if it is not signed? And if a signature is a digital signature, how is it assigned? Again, this is something which is not mentioned. And then there are ambiguity issues, that what does signing an electronic form means? Is this a physical signature or a digital signature? Again, this is not mentioned. And then there are a few other problems as well. For example, maintenance of copyright is one requirement, issue of document is another. So again, the few things have been jumbled up together. So these are the problems with the last requirement description that we saw. So it is very important, and at times, even we have gone through analysis, we miss on some things. And when we specify these requirements, that is why this validation process is important, that we do not want to leave any ambiguities in our document. We do not want to leave any inconsistencies, any incompleteness in our document. We want it to be complete, consistent, and unambiguous. So what can we do to facilitate this validation process? So prototyping is something that can be done to help all the team members, or to help end user actually visualize that these requirements are validatable. We have discussed prototyping as a solution to different problems. We have talked about prototyping during requirement elicitation as well. We say that prototyping can be done to actually ensure that the requirements are elicited, or they facilitate in requirement elicitation. Similarly, let's have a look at how prototyping can be used for validation. So prototypes for requirements validation demonstrate the requirements and helps stakeholders discover problems. So what we would do is that we have specified these requirements. We will make a prototype and show it to the stakeholders. And through that prototype, they might be able to identify if there are any problems in the finally specified set of requirements. So validation prototypes should be complete, reasonably efficient and robust. It should be possible to use them in the same way as the required system. So remember, there was a difference. We said that prototyping can be done for different purposes. One of the purpose of prototyping was to elicit requirements, and we said that those type of prototypes, they are normally called throwaway prototypes because we do not use them in a final system. Okay, whereas we are talking about validation prototypes, so we are saying that they should be efficient and they should be robust because we have spent so much time on our system already, and it should be possible to use them in a fashion similar to our required system. So user documentation and training should be provided. So for when you're using this prototype, this should be done as well. So what are the steps or what are the activities we perform when we are using prototyping for validation? We choose prototype testers, we develop test scenarios, we execute those scenarios and document those problems. And when we are developing those test scenarios and when we are executing those scenarios, we try to document and extend our prototype system as well. So when we say we are prototyping for validation, this can be considered the other type of prototype that we discussed earlier as well. We said one type of prototype is considered a throwaway prototype, which is used to elicit requirements from the client. And then the other prototype was actually to give functionality to the client. And then we are discussing now that prototyping can also be used for validation as well. So we are saying that the prototype that we develop for validating requirement, it should be robust and efficient, and it can be used in a similar fashion as we produce our original system. So what are the steps that we do during this prototyping for validation? We say we choose prototype testers. So we have to identify people who are going to test this particular prototype. So we have to identify a few end users, few domain experts who would test our prototype, and we need to develop our test scenarios now. Okay, and we need to execute those scenarios. And finally, we document all the problems. If there are any problems with the prototype, we document them. If no, then we go ahead with it. So this is what we do during prototyping for validating the requirements. So let's look at all these prototyping activities, that what is included in them. So when we say that we choose prototype testers, so what kind of people are most suitable for this job? So the best testers are users who are fairly experienced and who are open-minded about the use of new system. And we have mentioned this earlier as well during the elicitation process, that normally in every organization there are few people who know all the processes and who have lots of domain knowledge as well. But normally they are not that available. But they are the best testers, or so they are the best people to actually test this prototype that you're making. But they should also be open-minded, because normally there would be a lot of people in the company that would be against the new system that you're proposing. And no matter how good a prototype you make, they would always say, no, this is not right, and there are lots of problems with it. So you need to identify people who are experienced as well, and who are also open-minded to using new system as well. So end users who do different jobs should be involved so that different areas of the system functionality will be covered. Okay, so again, if you remember that review team membership, we said that people from different backgrounds and different skills should be part of that review team. So this is actually similar. When we are choosing these prototype testers, if we choose people who have multiple sort of skill set, or who have a huge skill set and who perform multiple things in an organization, they are kind of the best testers for a prototype that you are making. At developing test scenarios, careful planning is required to draw up a test scenario which provide broad coverage of the requirements. And this is something which is true for when we are writing test cases as well, and when we are performing testing as well. And this is sort of a very good research area as well, that people try to ensure that the test cases that they are producing, or the testing that they are doing, it covers the whole set of requirements. And what they do is they try to write minimal test cases, and they try to ensure that it covers the whole system or not. So end users shouldn't just play around with the system, as this may never exercise critical system features. So again, you need to identify very carefully that what are the things that need to be tested. So it's not that you just give them some prototype or give them a functional product and say, okay, go ahead and play with it, and if there are any problems, then report back. So you need to very clearly define those scenarios, that what are the things or what are the features that the client should try to use to help identify the problems in the system. And executing scenarios, the users of the system work usually on their own to try the system by executing the planned scenarios. So you would have already planned scenarios in the previous stuff which you have already developed, and the user would try to execute them on their own. So it's not something which is supervised where you are standing and telling them, okay, now do this, now do that, because you want the users to actually use the system and identify problems. And how these problems are documented, it's usually best to define some kind of electronic or paper report or paper problem report form which users fill in when they encounter a problem. Now this is something which needs to be reported back. And so normally different companies have deployed different electronic systems as well. So they would use, they would have a repository of all the bugs. So again, if somebody finds a bug, then they would report it. But if it's not electronic form, then there should be a hard form which people can actually fill. And so that why we want to fill this information in the forms is because we want to actually keep track of it, that what problems are identified during this validation and whether those problems have been fixed or not, and to whom these problems have been allocated to get fixed. So this is why this documentation of this is very important. So this is a very brief detail of what activities are performed during prototyping for validation. So another thing that can be done for validation is the user manual development. We discussed prototyping for validation. Now let's look at how user manual development can be used for validation. That writing a user manual from the requirements forces a detailed requirement analysis and thus can reveal problems with the document. So it is sort of, you have prepared something and you give it to somebody who is actually going to use it to produce something new, but he would go through that very carefully. So we are saying that, we will look at all the requirements, and we'll look at all the functional requirements, all the non-functional requirements, and we are going to prepare a user manual. And we're going to say, okay, when you press this button, then this happens, and if you're trying this process, what would happen, what are the steps you need to execute to actually perform registration, for example. And when you're preparing this user manual, and you are describing that how, for example, a student wants to register a new course, and you try to figure out, okay, this requirement mentions something about registration, and later on you find another requirement which says again something about registration. And when you are preparing the user manual, if there is conflict between the two, and if there is redundant information, you would be able to identify, okay, that there is a problem in this document because it mentions that this registration process is done in two different ways, or this is just redundant information because you have already said it. So again, this is another technique which can be used for validation. So what is the information that is present in a user manual? It describes functionality and how it is implemented, which parts of the system have not been implemented, how to get out of trouble, and how to install and get started with the system. So these are the things that normally are part of user manuals. So user manuals are also useful for validating requirements, because when we are preparing this user manual, we can identify the problems in the requirements. So what is model validation? Validation of the system models is an essential part of the validation process. So what are the objectives of model validation? To demonstrate that each model is self-consistent. If there are several models of the system, to demonstrate that these are internally and externally consistent. To demonstrate that the models accurately reflect the real requirements of system stakeholders. Some checking is possible with automated tools. Paraphrasing the model is an effective checking technique as well. So this is what model validation is about, and we have discussed different kind of models. We have discussed some scenario-based techniques. We have discussed in those we have discussed class-based models. We have discussed data flow diagrams. So what we can do is we can sort of validate those models as well, whether those models were correctly applied or not. So let's look at one of these examples. So this is a data flow diagram for the issuance of a certain item from library. So let's say you have this library card, and we check the user, where the user is actually a valid user of the system, so user details are also part of it. and then we check a particular item. So the first thing that you ensure is that whether the user is a valid user of the library, and then depending on whatever the user status is, so the output from this particular process is the user status, that okay, this is a member, or let's say we say that this is a member of the library, and then we check the item. So let's say you look for a particular item in the system, and then you find the item status, that whether it is available or whether it is borrowed or not, and depending on that you issue the item. So if the item is issued, then your details are also updated that this user has issued this another book or not. So you can look at these models, and you can also validate these models, that whether they are correct or not. And then you can also have these paraphrase description. As we said that paraphrasing the model is an effective checking technique, because we want to ensure that the model that we are using, that is self-consistent. Okay, so we can actually paraphrase it, and we can identify if the model is correct or not. So for example, paraphrasing is, if you remember, then there is something that we discussed in those in that flow-oriented modeling. We said that processing narratives. So that is actually paraphrasing of the process. So how can we paraphrase this last example of data flow diagram? We can say that what are the things that we do in check user. So what are the inputs and sources? So we are saying that user's library card from the end user is an input to this process. Similarly, what is the transformation function that is applied? We are saying that whether the user is a valid library user or not. So that is what we are checking in this particular process. What are the outputs? So we are saying the output is the user status. And what is the control information? User details from the database. Because depending on that information, we are actually ensuring that the user is a valid member of the library or not, and based on it, we are this transformation process, it produces an output that which is user status, that whether he is the member or he is not a member. So by paraphrasing it, we can sort of identify that if there are any inconsistencies in this document, if there is any missing information in this document, or if it is incomplete to a certain extent or not. And the next process was to check the item. So what we are ensuring here is that the user status from the check user, so that is the input. Okay, and then checks what this process actually doing is, it is checking if an item is available for issue or not, and transformation outputs is the item status, whether it is available or not, whether it is borrowed, somebody else has already borrowed it. And then we have this control information, which is availability of this particular item from the database. So you're going to see whether a certain book that is being requested by this user, whether it's available or not. So this is how we paraphrase a model. And by paraphrasing it, we can actually identify if, for example, we said that the model should be self-consistent, or it should be self-contained. So we can actually see that all the information that is required for this particular process is actually in there. We know that what is the control information, we know that what are the different outputs, what are the inputs to these processes, and we know what is the transformation function that is being applied. So we can do this model validation, and by validating these models, we can identify if the requirements are complete, consistent, unambiguous, and we can also sort of identify if there are any technical problems with the requirements. And we have said that there are some automated tools available. By using those tools, we can check the consistency of the model, if there are any consistency problems, if there are any contradictions in the model or not. But we can paraphrase it as well, which is sort of manual. But paraphrasing is also a very helpful way of identifying problems with the different models that you are using. Then comes requirements testing, and requirements testing is also considered to be part of validation as well. As we have already said, that one of the features of a requirement should be that all the requirements should be testable. So we need to ensure that whatever we have written, we can write a test case, we can develop a test scenario through which we can actually test this particular requirements. So it should be possible to define tests to check whether or not that requirement has been met or not. We have already discussed that. Inventing requirement test is an effective validation technique, as missing or ambiguous information in the requirement description may make it difficult to formulate tests. So this is something similar to writing user manuals. Because when we are preparing user manuals, we are going through that requirement specification document, and then we are trying to prescribe that this is how the end user can use the system to perform certain functions. Whereas when we are preparing those test cases, now this is something that you're doing for your own team and you're preparing those test cases, but in doing so, whenever the software quality assurance team member, they're preparing those test cases, they're going through that requirement specification document, and they figure out that something has not been clearly mentioned. And if that is the case, they would say, okay, there is incomplete information which makes this requirements untestable, and we cannot actually completely define this test scenario. So each functional requirement should have an associated test. So normally we say that, let's say there are multiple requirements, R1, R2, R3. So our requirement should have at least one test case. Okay. But it can happen that, there can be multiple test cases for one requirement. So this can happen as well, but each requirement should have a test case where it is tested. So there can be sort of multiple sort of relationships between different requirements and between different test cases. So it can happen that one test case tests multiple requirements. It can happen that multiple test cases are used to test one particular requirement. So all these things are possible. But at least each functional requirement should have a test case where that requirement is tested or not. So how do we define these test cases? So what usage scenario might be used to check the requirement? So that is how we think about, okay, what is the test case? Does the requirement on its own include enough information to allow the test to be defined? Is it possible to test the requirement using a single test, or multiple test cases are required? So as I said that, for example, we are preparing a test case for this requirement 1, and we figure out, okay, no, this is not testable requirement because it does not contain complete information. So maybe we sort of identify that, this requirement, it needs to be merged with another requirement, or there is some missing information which needs to be included in this requirement. So this is how we try to validate requirements as well. So we say, okay, no, this test case cannot be defined based on this. We need some detail which is given in R2 to actually define this test case. So that is how we try to identify that whether there is any missing information or not. Could the requirements be restated to make the test cases more obvious? So for example, we may need to restate this requirement, and then test case 1 can be written for this particular requirement or not. So when we are defining these test cases, first thing we try to figure out is that under which usage scenarios this requirement can be tested, and then we check that whether the information that is given in one requirement, is it enough to actually prepare a test case for it. Then if not, then we try to figure out whether this requirement can be restated in a different fashion, so that it contains all that information necessary to conduct that particular test case or prepare a test case against it. So normally when we are preparing these test cases, we have a test record form as well. So what are the information which is included in this test record form? We have the requirements identifier. So there should be at least one for each requirement. We had related requirements. So for example, let's say we are testing requirement number 4, requirement number 5. So that would be the requirements identifier. And all the requirements which are related to this particular requirement, we will also sort of list all those requirements. Then we will write a test description, that what usage scenario, through which usage scenario this requirement will be tested. That would be the test description. And so what we are going to write in it, a brief description of the test, why this is an objective requirements test, and this should include system inputs and corresponding outputs. Then the requirements problems, a description of the problems which made test definition difficult or impossible. And this is the bit which is actually useful for this validation process, and that is why we say that test cases are normally are prepared very early on during this whole life cycle of the product or system development life cycle, because we prepare this SRS, then we prepare the test cases as well, and they serve two purposes. Number one, they serve the purpose of requirement validation as well. Secondly, the test cases, they're also another product out of them. And then finally, we have some comments and recommendations as well. And these comments and recommendations, these are advice on how to solve these requirement problems which have been discovered. So let's look at one of these examples. So for example, we will have this in the requirement tested. We say that, okay, this is the identifier of the requirement which is tested. And then we have these related requirements where we say that all these requirements, they are related to this particular requirement. Then what is the test which is applied? So we are saying that why this is an objective test, and what are the inputs and what are the outputs of this particular test. So we are saying for each class of the user, prepare a login script and identify the services expected for that class of the user. So we are trying to prepare a test case which would actually ensure that different kind of users can log in into the system, and we also need to check that whether they have access to the right kind of services depending on their authentication level. So the results of the login should be a web page with a menu of available services. For example, you have different kind of users on your web page. You have administrator, you have a normal user, you have I don't know, a master user. So whenever they log in, the set of services that should be available to them are only for which they are allowed. So for example, administrator should have services such as add user, delete user, modify user, whereas a normal user should have he can just view, or he can request for a specific kind of a report, or so this is the output of this particular test case. So what is the problem? So let's say, how do we write the problem? We don't know the different classes of EDIS user and the services available which are available to each user class, apart from the administrator or all other EDIS users in the same class. So this is the problem, that we don't know that what are the different types of user to this system. We only know that there is just administrator. So are we considering all other users to have same sort of rights? So we have listed that this is a problem. So what are the recommendations or comments for when we prepared this particular test case for requirement number 4? So what are the recommendations? Explicitly list all the user classes and the services which they can access. So that is a problem or sort of incomplete information that we have identified in requirement by the process of writing this test case, that we say that you need to explicitly define all the user classes and the services which they are allowed to access. So that's how this preparing these test cases is helpful for validating the final set of requirements. So I guess that is it from today's lecture. And we will continue our discussion from where we left off. Let's quickly try to recap what we have done in our lecture today. So in today's lecture, we have covered validation process, and specifically we talked about review team membership, that who are the people who can become members of this review team, or what sort of stakeholders to be included during that requirement review process. So we said ideally people who perform different activities, who have knowledge of different processes, who have multiple skills, they are the best people to be included in that review. And as a minimum, we said that a review process should include at least an end user and a domain expert. We want people with diverse skills because they would be able to identify the problems with the requirements. They would be able to identify conflicts, inconsistencies, or contradictions in the requirements. Then we also discussed the review checklist, that we need to ensure that whether the requirements, we prepared a checklist of almost 10 things which we ensure. We check the requirements for completeness, we check requirements for redundancy, we check requirements for contradictions, for consistencies. So these checklists, they are always a very useful tool to actually ensure whether we are actually following a certain thing or not. And specifically in this case, we prepare a checklist for validating requirements. Then we discussed few of the other techniques which can be used to validate requirement. We discussed prototyping. And we have said that prototyping is a solution which can be deployed in multiple scenarios. We have discussed already prototyping during elicitation. Similarly, prototyping can be used for validating requirements. So we discussed in detail what would be a prototyping process. So we said that the first thing that we need to do is to identify that who will be by prototype testers. So that is very important, to identify that who would actually test this particular prototype. And then we said that we prepare test scenarios and we conduct those tests, and then finally we report problems. So again, one of the most important thing here in this prototyping and when we use prototyping for validating requirement is that who are the users who would act as the testers of this prototype. And again, something very similar to what we discussed in review team membership, that the people who have knowledge of multiple processes, they are sort of best candidates to be involved in this prototyping testing process. And then we said that another technique which is very useful for validating requirements is preparation of user manuals. That when we prepare these user manuals, we go through that software requirement specification document, we go through each functional and non-functional requirement. When we are listing or prescribing those processes for the end users, we can identify problems in the requirements. Then we can also perform model checking. So model checking is a very useful technique through which we can identify the different models that we have used to expand or analyze our requirements, whether there are any inconsistencies on those requirements. One of the examples we saw of an issuing a book from a library or issuing a certain article from library, we saw that that particular process, we can actually go through those processes. So we looked at this example, and it had multiple small processes. For example, you were checking the user, you were checking that particular item, then you were checking the status of that item, and finally the item was issued, and the details of the user, they were updated. So if there are any contradictions or if there are any missing information, that how the user authentication would be checked, how the user rights would be checked, how the item would be checked, if there is any missing information, we can actually identify it. And with this model checking, there are some automated tools also available through which you can actually validate your models, but you can also paraphrase those models. And by paraphrasing, we actually mean you actually prescribe those models, and through that you identify, okay, if there is something missing in this particular model that we have prepared. And then finally, another technique which is very useful for validating requirements is preparation of the test cases. So we prepare test cases, and during that preparation process, we sort of identify whether does each requirement has enough information to for it to be tested on its own, or is there something missing? If there is something missing, we try to figure out, okay, can this requirement be stated in a different fashion so that it becomes testable or not? So preparing test cases is also a very good way of identifying problems or validating these requirements. So that is it from today's lecture. Inshallah, we will continue our discussion on this validation process in the next lecture. Till then, take care and Allah Hafiz.